All right, calcularians, here we go. Today we are going to look at the relationship of the derivative with a original function, specifically talking about how to recognize concavity using the first derivative. So here I have a function f of x, and I'm going to say this is an odd degree polynomial because it's beginning and ending are opposite, odd degree. And I'm going to go with, this could be at least a 1, 2, 3, 4, 5 zeros, so at least a fifth degree polynomial. So I know f prime of x will be a fourth degree. So I'm just going to make a little note of that. Now I always like to start graphing my derivative by recognizing the zeros. So I've got a maximum there, so I'm going to have a derivative 0, minimum will be a 0, another max, a 0, and finally this relative minimum will also be a 0 on my derivative. So my f of x starts, when I trace my f of x, it's increasing, decreasing, increasing, decreasing, increasing. So to show on my function here, my derivatives, the slopes of the tangent lines at every single point, and here this is getting a little hard, but here I can kind of get the idea. If I graphed a bunch of derivatives, a bunch of slopes of tangents at every single point, they're all positive on this part of the graph. Positive, 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 0, negative, 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 0, positive, 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 0. So I'm going to follow that trend. When my function is increasing, my derivative is positive. When the function is decreasing, negative, but going back to 0. Increasing, so derivative positive, going back to 0. Decreasing, negative, going back to 0, and then increasing. Boom. So there is my fourth degree. Notice both ends going up. 1, 2, 3, 4 zeros. There's a graph of the derivative. Now the last thing I want to tie in here is concavity. So my original function f of x changes concavity multiple times. Here the graph is concave down, and right around here I would say my graph changes from concave down to concave up. So right around there I'm going to put an x. And this continues. Now I'm concave up, but right around here, it goes from up to down. I'm going to keep following along here, down, 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 down. Right around here, I'd say my graph changes to up. So I have 1, 2, 3 places where my original function in blue, the f of x, changes concavity. And what I want to do is really emphasize, what is the derivative doing? So here, concave down matches up right there on my derivative. What is the derivative doing? It's decreasing. Here we go. Increasing, concave up. So from here to here, my f prime of x is increasing, and my function, f of x, is concave up. I know, right? It's awesome. Let's see what happens after that. Decreasing, f of x is concave down. So when f prime of x decreases, f of x concave down. And then let's look at the very end here. This is kind of awesome. These points almost overlap, but here I change from concave down. From this x onward, I'm concave up, and my f prime of x is increasing. So again, that relationship, when the derivative is increasing, your function is concave up. Boom, there you have it. 4 minutes of graphing and wonder. 5 minutes. Hopefully you can play around and mess around with this and it sinks in. And I really hope you enjoyed the video. If you did, please like it and subscribe to my channel. Way to go, calcularians. I departed way too early because I wanted to look at one more example. So here we're back again after a brief intermission, because let's look at a derivative and see if we can recreate the magic of f of x based on the derivative here. So it looks like my f prime of x is a third degree cubic, so because I've got 3 zeros, 1, 2, 3. And if I have 3 zeros on f prime of x, then I know I have 3 extrema on f of x. So this first example, or this first step at this 0, I go from positive to negative, which means if I put my magic hands up here, positive to negative, I create a maximum point there. So I'm just going to have my graph start down here. This is telling me I'm increasing up until this point right here, and then I start decreasing until I hit this point. So I am going to increase till I hit that point, start to decrease, and I hit this other 0 where I am decreasing and then increasing. What does that form? When I decrease and then increase, I'm forming a minimum here. And if I keep following along, my graph is again positive. The derivative here is positive all the way to this last 0 and then negative, which means I'm going to increase, 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 then start to decrease. Increase, 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 decrease. So my zeros match up with my extrema. Zeros, extrema, zeros, extrema. And let's check out that concavity. So here, I would say I am concave down. Right about here is where it changes to up. And notice the derivative is decreasing that whole entire time. This is where they match up. Concave up, 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 up. Where does the concavity happen? The concavity is going to change from down to, from up to down, up to down. What is f prime doing? Increasing to decreasing. So the behavior f prime of x, when it's increasing, concave up, decreasing, concave down on the original function. It worked. Boom. Like the video, subscribe to my channel. Way to go, Calcularians.